this video tutorial, we will demonstrate to you the project tree and its functionalities. The project tree is one of the core GUI elements of the software. After starting a new session of the software, the project tree is empty, as there is still no project loaded. One can either create a new project or open the existing one, as already partly covered in our introductory video, Overview of CF Mesh Pro. In this video, we will show to you how to open an existing project by demonstrating and using the project tree functionalities. By right-clicking on the project tree No Project root node, a context menu appears with the options to create a new project or to load an existing one. We will choose the second option and load the already existing demo project. Once the project is loaded, the project tree structure with project cases appears. If not already selected, please select the Flange 1 case by double-clicking on it and expand the case tree by clicking on the small arrow next to it. Now that the project is open, the root node context menu offers functionalities to create a new case or import an existing one. We will not do this at this point in time. By right-clicking on Flange 1, a context menu appears with the options to select, save, export, remove, copy or rename the case. The functionalities are self-explanatory. To copy the selected case, which is Flange 1 in our case, to a new one, please select the Copy functionality and give a name for the new case. A new case has been created which is exactly the same as Flange 1, but just with a different name. The case can be removed by using the Remove functionality. The user is prompted to decide whether to delete the case from the disk as well. In our case, we will choose Yes. In addition, there is one functionality for advanced users. By right-clicking on the case node and selecting the Edit Dictionaries option, one can access the ASCII editor for dictionaries that are present in the case. In our case, there are present control-dict and mesh-dict directories. These are the standard OpenFOAM and CFMesh input files, which are taken care of directly by the application, and the users are discouraged of editing them via this editor unless they are expert users and know exactly what they're doing. For the moment, our case is empty, as there are no surface or volume meshes yet in the case. To import the surface mesh into the case, right-click on the Surface Meshes node and select the Import FMS option. FMS is the standard surface mesh format used by CF Mesh Pro, and how to obtain the FMS from another surface triangulation file will be shown in another video tutorial. Select the flange.fms file from the root demo directory and click on the checkbox next to the imported surface mesh. The surface mesh is now imported to the project and shown in the viewer. The child nodes of a surface mesh are patches, point subsets, face subsets, primitives, and auxiliary objects. How any of these elements are properly applied in preparing a surface mesh for the meshing procedure is a topic of subsequent tutorials, and here we will mention only the basic information about them. Patches are probably the single most important surface and volume mesh topology elements. In our example, there are 4 patches named Patch 1 to Patch 4. The purpose and most important use of patches is in marking off the simulation domain boundaries. Within the simulation context, the patches usually represent, in a meaningful way, the domain boundary sections, where boundary conditions are imposed. As such, there is a restriction that the patches must not overlap. Within the meshing procedure, patches identical to those on the surface mesh are automatically created on the volume mesh. Patches can be selected or deselected. Also, patches can be given a type, renamed, deleted, or given a specific color. Also, 2 or more patches can be merged into a single patch. Filters can be applied to show only those patches with certain string in their names. This feature can be extremely useful, especially in those examples where there are tens or hundreds of patches defined in the surface mesh, and navigation through all the patches would be very difficult in those cases, unless there was a way to narrow down the number of shown patches. Of course, this feature is useful only in case the patch names are given in a smart and meaningful way. For instance, naming patches on the inlet boundaries as Inlet 1, Inlet 2, Inlet 3 or similar would do the work. A selection of multiple patches can be done by clicking on the patches and holding down the Control key. Alternatively, a series of adjacent patches can be used by holding down the Shift key and clicking on the first and the last patch in the series. Patch operations are in most cases also available on selections of multiple patches. If, for instance, one wanted to select all patches, the best way to do it is to do a selection of all patches and apply the Select All functionality. In a similar way, a patch type can be given to a single patch or to a selection of patches. Once selected, the basic info regarding the selected patch is automatically displayed in the Info window. Likewise, the info regarding the surface mesh as a whole can be obtained by selecting the surface mesh node in the project tree. The same applies for the volume mesh and its elements. Point and face subsets, as their respective names indicate, are subsets of points and faces respectively, and in many situations can prove useful in preparing the surface mesh for the meshing procedure. Face subsets, unlike patches, can overlap. The most likely usage of face subsets in the meshing process is to demarcate zones on the simulation domain boundary where mesh refinement is needed. Similarly, primitives are also frequently used to demarcate the mesh refinement zones, but in this case not on the domain boundaries, but rather inside the simulation domain. Among primitive types currently supported in the application are the box, bounding box, sphere, cone, cylinder, plane and line primitives. How to use primitives in defining refinement meshing zones will be shown in other video tutorials. In a similar way, like primitives, auxiliary objects like triangulated surfaces can be used in defining the refinement zones. Those can be imported to the project. Finally, the tree structure of the volume mesh is in part similar to that of the surface mesh, however with some additional elements. Please select the Flange 2 case and load the volume mesh. We see that the patches are the same in both the surface mesh and the volume mesh. There are point and face subsets elements also present in the volume mesh. However, the primitives and auxiliary object elements are not, as they are only meaningful when used as inputs in the meshing procedure. In addition to surface meshes, in volume meshes there are also elements for cell subsets and point, face, and cell zones. The meaning of those elements will become evident and showcased in the upcoming videos. Thank you for watching this video.